Project Mercury was NASA's first human spaceflight program. In the heat of the Cold War, America faced a challenge: get a man into space before the Soviets took the lead. With only 6 crewed missions from 1961 to 1963, Mercury was all about proving that humans could survive and work in space. But before NASA could send these astronauts into the unknown, they first had to ensure that spaceflight was safe for animals in general. The first launch of a great ape was Ham the chimpanzee. His mission was a success and paved the way from the first crewed missions. In 1959, NASA selected 7 brave astronauts known as the Mercury 7, of which only 6 flew on missions, including legends like John Glenn and Alan Shepard. In 1961, Shepard became the first American in space, riding the tiny Mercury capsule on a 15-minute suborbital flight. Project Mercury paved the way for Gemini, Apollo, and the moon landing. It was America's first giant leap toward space exploration. Project Gemini. As the space race was heating up and NASA had sent the first Americans to space with Project Mercury, but to win the space race by landing on the moon was still far out of reach. To get there, astronauts needed to learn how to fly long missions, dock spacecraft, and work outside their capsules. That was the mission of Project Gemini, NASA's second human spaceflight program. Between 1965 and 1966, 10 crewed missions pushed spaceflight to the next level. Gemini 4 saw astronaut Ed White become the first American to perform a spacewalk. Gemini 5 and 7 proved astronauts could survive in space for 2 weeks, long enough for a moon mission. Gemini 6 and 7 achieved the first ever rendezvous, proving that 2 spacecraft could meet and fly together. Then came Gemini 8, when Neil Armstrong and David Scott completed the first docking in space, only to face a dangerous spin that nearly ended in disaster. Armstrong's cool-headed piloting saved the mission and foreshadowed his future heroism. Every Gemini mission was a test for the moon landing. It refined spacecraft design, trained Apollo astronauts, and proved NASA was ready. Without Gemini, there would be no Apollo 11. It was the training ground that made the moon landing possible, the Apollo program. Before Neil Armstrong's famous first step, NASA's Apollo program had to overcome enormous challenges. It all started with the desire to win the space race and step foot on the moon first, and that's when John F. Kennedy made his famous speech.
Why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon this decade and do the other things, not because they are easy, but because they are hard.
The journey began with Apollo 1, tragically lost in a cabin fire during a test in 1967. But from that loss came critical safety improvements. Apollo 7 was the first successful crewed mission, proving the command module worked in Earth orbit. Then, Apollo 8 became the first mission to leave Earth's orbit and orbit the moon, giving us the famous Earthrise photo. Apollo 9 tested the lunar module in Earth orbit, and Apollo 10 did everything but land, coming within 10 miles of the moon's surface. Then came Apollo 11, the moment the world had been waiting for.
It's one small step for man, one giant leap for mankind.
The USA continued launching Apollo missions, all of which, bar Apollo 13, were successful. With all missions after Apollo 15, including rovers on board, with Apollo 17 being the last time we have been to the moon to date. The Apollo program didn't just land humans on the moon, it changed our understanding of space forever. Its legacy still fuels space exploration today. Skylab. Skylab started off rough. A micrometeoroid shield ripped off during launch, damaging a solar panel. But NASA's engineers and astronauts quickly improvised. The crew of Skylab 2 made emergency repairs, saving the station and proving humans could live and work in space for months at a time. 3 crews, Skylab 2, 3, and 4, spent a total of 171 days in space, conducting groundbreaking experiments on the human body, the sun, and even Earth itself. Skylab gave us the first detailed images of solar flares and helped NASA prepare for future missions, like the Space Shuttle. Planned upgrades were canceled, and in 1979, Skylab fell back to Earth, scattering debris over Australia. But its legacy lived on, paving the way for modern space stations. Now, with plans for new lunar bases and missions to Mars, Skylab's story is more important than ever. The Space Shuttle program. For 30 years, NASA's Space Shuttle program made spaceflight routine, launching satellites, building the International Space Station, and inspiring a generation. The first shuttle, Columbia, launched in 1981, marking a new era of reusable spacecraft. Unlike traditional rockets, the shuttle was part spacecraft, part airplane, designed to be used again and again. 5 orbiters, Columbia, Challenger, Discovery, Atlantis, and Endeavour, carried astronauts, satellites, and even repaired the Hubble Space Telescope, giving us breathtaking images of the universe. The shuttle was essential to building the ISS, delivering large modules, supplies, and rotating crews, creating a permanent human presence in space. But the program faced tragedy. Challenger, 1986, and Columbia, 2003, were lost, reminding us of the dangers of spaceflight. Yet, from loss came lessons, leading to improved safety for future missions. After 135 missions, the shuttle was retired in 2011, with the last mission flown by the Atlantis. Making way for new spacecraft like NASA's Artemis program and commercial spaceflight with SpaceX and Blue Origin. The Space Shuttle paved the way for today's missions and the journeys to come. Shuttle-Mir. In the Cold War, the US and Soviet Union were space rivals. But in the 1990s, they became partners. The Shuttle-Mir program was the first step toward international cooperation in space. Between 1994 and 1998, NASA's Space Shuttle docked with Russia's Mir space station 9 times, training astronauts for long-duration spaceflight and testing technology for future missions. American astronauts lived on Mir for over 975 days, conducting scientific experiments and proving humans could work together in space. They studied microgravity, medicine, and life support systems, lessons that would help build the International Space Station, ISS. But it wasn't easy. Mir suffered fires, power failures, and a dangerous collision with a supply ship. These challenges tested astronaut resilience and shaped future space safety protocols. By 1998, Shuttle-Mir ended, making way for the ISS, a direct result of this groundbreaking partnership. Shuttle-Mir showed that space isn't about competition. It's about working together for the future. The International Space Station. Orbiting 250 miles above Earth, the International Space Station, ISS, is the largest and most ambitious space project ever built. A symbol of international cooperation, it has been home to astronauts for over 2 decades. The ISS began in 1998 when Russia's Zarya module launched into orbit. Soon, NASA's Unity module joined, marking the start of a global effort. Over 40 missions would follow, assembling the station piece by piece. Built by 15 nations, the ISS serves as a floating laboratory, testing medicine, biology, and physics in microgravity, research that benefits both space exploration and life on Earth. From growing food in space to developing new materials, the ISS has prepared us for future missions to the Moon and Mars. It's also a training ground for deep space travel, teaching us how to live and work in space for months at a time. With new spacecraft like SpaceX's Crew Dragon and plans for a lunar space station, the ISS's legacy will continue to shape the future of exploration. The ISS proves that space belongs to all of us, and that together, we can go even further. The Commercial Crew Program. For almost a decade, NASA relied on Russia to send astronauts to space. But with the Commercial Crew Program, American rockets are flying again. Started in 2010, the program aimed to develop privately built spacecraft to transport astronauts to the International Space Station, revolutionizing space travel. NASA partnered with SpaceX and Boeing to design safe, cost-effective, and reusable crew vehicles. Crew Dragon by SpaceX, CST-100 Starliner by Boeing. In 2020, Crew Dragon made history with Demo 2, launching astronauts from U.S. soil for the first time since 2011. Since then, it has become NASA's primary ride to space. Meanwhile, Boeing's Starliner has faced delays and left their first crew stranded on the ISS, but will soon join Crew Dragon, providing another option for crewed spaceflight. The commercial crew program is just the beginning. As private companies take the lead, space is becoming more accessible than ever, paving the way for missions to the Moon, Mars, and beyond. From NASA to the private sector, space travel is entering a new era. The Artemis program. For the first time in over 50 years, NASA is sending humans back to the Moon. This is Artemis, the program that will take us beyond the Moon and toward Mars. Since Apollo 17 in 1972, no human has set foot on the Moon. But now, NASA is building a permanent lunar presence, with Artemis paving the way. The program is named after Artemis, the twin sister of Apollo, symbolizing a new era of lunar exploration, one that will land the first woman and first person of color on the Moon. Artemis isn't just about landing on the Moon, it's about staying. NASA plans to build the Lunar Gateway, an orbiting space station, and a permanent moon base to test technology for future Mars missions. The first step was Artemis I, an uncrewed test of the Orion spacecraft in 2022. Next, Artemis II will send astronauts around the Moon, and Artemis III will land humans on the lunar surface. NASA is partnering with SpaceX, Blue Origin, and international space agencies to make this vision a reality. The Artemis program is just the beginning. The Moon is our stepping stone. Mars is next. That was every manned NASA program to date. What do you think about the future of spaceflight? Leave your thoughts in the comments and don't forget to like and subscribe.